Good morning, everyone. I'm Shashwathi Shetty. It is my privilege to present my paper on the subject Experimental Study on Lateritic Soil Stabilization with a natural lime and OPC using wet UCS tests. To start with, we know in the present era, the recycle, the reuse, the protection and the enhancement of the natural resources have become a major concern because these natural resources are highly exploited. In the field of construction, the utilization of the natural resources are very high. So to meet this requirement, we have come up with a study which includes the stabilization of a naturally available lateritic soil with a natural lime, that is using seashell and the eggshells, and along with the utilization of the OPC, which is nothing but ordinary Portland cement, so that we can come up with a cost effective and eco-friendly block. Also, with the process of stabilization, it helps in enhancing the physical as well as the chemical properties of the soil. Thus, with this study, we can also make sure this soil can be utilized in the construction of the pavement. So, before conducting this study, we have gone through various papers to know the feasibility of the utilization of the lateritic soil along with the OPC and the lime. So some of our major objectives to start this study are to investigate the usage of the natural lime along with the OPC in the field of construction. Can this be utilized as a construction material? Secondly, to come up with the cost effective and eco-friendly construction material. Also, we can utilize this waste products such as egg cells and the seashells effectively, and also the lateritic very waste. When I say lateritic very waste, we have utilized this waste soil which is unused after the carving of the lateritic blocks. And also, it is a small attempt to improve the properties of the subgrade soil so that it can be used in the construction of the flexible pavement. Methodology which we have utilized are, first of all, we have collected the naturally available products, and that is the naturally lateritic soil as well as the natural lime and the OPC. And we have conducted various laboratory tests to determine the geotechnical and the engineering properties of the lateritic quarry waste, the natural lime, and the OPC. We have conducted various tests by adding the lime and OPC in different proportions by weight to the soil, and further we have also calculated the strength of the soil. And finally, we have also conducted the CBR test, which is very much important to check whether the soil can be utilized in the construction of flexible pavement. And also UCS compaction test is also conducted for the various proportion to know the strength of the soil. Experiment which we have conducted are mainly specific gravity of lateritic soil, dry sieve analysis and wet sieve analysis of the lateritic soil, the water content of the lateritic soil, the standard Proctor test for the plain lateritic soil, and also for the various proportions of the lime and the OPC with that of the lateritic soil. And we have also conducted CBR test and the compressive strength test. And here are the results. The specific gravity of the soil was found to be 2.62. The dry sieve analysis test was conducted, and the uniformity coefficient was found to be 7.78, and the coefficient of curvature was found to be 2.66. With the help of wet sieve analysis, we got to know that this soil is suitable for the pavement construction. The water content of the soil was found to be 15.5 to 6%, which pretty much good. And also the liquid limit was found to be 40%, and the plastic limit was found to be 33.48%, which which gives us which makes this soil suitable for the construction of block. And we have also done standard Proctor test for the plain lateritic soil, and the maximum dry density of the plain lateritic soil was found to be 1.71 kilonewton per meter cube. The optimum moisture content, that is OMC, was found to be 22.47%. And we have done the same experiment on various proportions, that is 2:3, where 2 is the percentage of the lime and 3 is the percentage of the OPC used. And here for the 2:3 ratio, the maximum dry density was found to be 1.83 kilonewton per meter cube, and the OMC was found to be 22.857%. And similarly for 3:4, you can see the maximum dry density was 1.88 and the OMC was found to be 22.88%. And for 4:5, the maximum dry density was found to be 1.68 and the OMC was found to be 21.62%. And we have also conducted unconfined compressive strength test on the lateritic soil with lime and OPC. First, we have conducted it only for the lateritic soil, and it was found to be 0.165 kg per centimeter square, and the shear strength was found to be 0.082 kg per centimeter square. For 3:4 ratio, it is found to be 0.199 kg per centimeter square, and the shear strength was found to be 0.099 kg per centimeter square. And that for the 4:5 ratio, it was found to be 0.276 kg per centimeter square, and strength of the soil was found to be 0.138 kg per centimeter square. You can see the value of the UCS is increasing gradually. So we have also conducted a compressive strength on the blocks which we had casted, and here are the results of the same. For 14 days, it was found to be 355.36 kilonewton per meter square. And these are the various pictures of the experiment we have conducted. And the conclusion part, with this experiment, we got to know the compaction test, the maximum dry density of the stabilized lateritic soil increased when compared to that of the naturally lateritic soil. With the inclusion of the lime and OPC with the lateritic soil, the chemical properties increased. So it enhanced the physical and the chemical properties of the soil. So that is why the maximum dry density of the lateritic stabilized lateritic soil was found to be more when compared to that of the plain soil. We have the maximum dry density of the stabilized lateritic soil for 3:4 was the highest when compared to that of the natural soil. So it gave us we have used 3:4 ratio for the construction of the blocks, because in this particular ratio, the OMC as well as the maximum dry density was highest. So we utilized this, making it suitable for the casting of soil. So we have utilized this. The natural lime and OPC is mixed with lateritic soil, and the CBR value increased for various proportion. Also the CBR value increases. So when this when the CBR value increases, it means the chemical and the physical properties of soil is increasing, and the soil has the higher strength when compared to the normal soil. So which makes it suitable for the pavement construction. So according to the IRC 37/2012, this mixture which we have prepared is suitable for the flexible pavement construction. So we have also prepared the soil blocks, but we didn't get the results we were looking for. The strength of the block was not as much as we were expecting, so thus making this soil unsuitable for the main block construction. But then these blocks can be used as a partition walls, and also it can be used in the other places where the load strength or the load acting on those walls will be less. So we can use these blocks in the partition walls or in the compound wall. And also with these blocks, the plastering is not a problem. There is no need of having additional plastering, because these blocks are very smooth and they have a very smooth surface. Thus the we can it thus it will reduce the cost on the plastering. So these blocks are cost effective as well as eco friendly, because we have used naturally available resources, or which doesn't have any contamination, or which is not toxic in nature. So these are eco friendly as well as cost effective. We This was one of the major reason why we have done this study. We just wanted to come up with a product which is cost effective and eco friendly, and it can, and hoping that this product will be used as an alternative building material. So this is a very small uh, try from our side to come up with the alternative building material, so that we can reduce the burden on the natural resources, and we can use various other naturally available products, so that we can come up with something innovative which will be cost effective as well as eco friendly. Thank you for this wonderful opportunity. Thank you, one and all.